Good day everyone. Today I will present to how to solve a circuit using nodal analysis with complex numbers or phasor form. This problem asks us to find the node voltages V1 and V2 using nodal analysis. First, let us examine the circuit. We have two nodes, V1 and V2. There is a 20 angle 45 degrees impedance between the nodes. A 10 angle 0 degrees connected to V1 and 15 angle 0 degrees connected to V2. And we also have two current sources. 6 on the left side, we have 6 angle 20 degrees amperes and 4 angle negative 30 degrees amperes. Next, we assign node voltages. We define V1 as node 1 voltage and V2 is node 2 voltage. The bottom line is considered the reference ground. Now, we apply Kirchhoff's current law at node 1. The sum of currents leaving node 1 is equal to the current source. So V1 over 10 angle 0 degrees plus V1 minus V2 over 20 angle 45 degrees is equals to 6 angle 20 degrees. Now let's convert impedance to admittance by taking reciprocal of each impedance value. So 1 over 10 angle 0 degrees equals to 0.1 angle 0 degrees. And 1 over 20 angle 45 degrees equals to 0.05 angle negative 45 degrees. So the equation becomes 0.1 angle 0 degrees V1 plus 0.05 angle negative 45 degrees times V1 minus V2 equals 6 angle 20 degrees. Now we apply Kirchhoff's current at node 2 and follow the same procedure. V2 over 15 angle 0 degrees plus V2 minus V1 over 20 over 45 degrees equals 4 angle negative 30 degrees. So let's convert again to admittance. 1 over 15 angle 0 degrees equals 0.067 angle 0 degrees. So the equation becomes 0.0667 angle 0 degrees V2 plus 0.05 angle negative 45 degrees times V2 minus V1 equals 4 angle negative 30 degrees. Now let's convert all phasor values into rectangular form. This helps simplify calculations and allows us to solve simultaneous equations easily. So 0.05 negative 45 degrees becomes 0.0354 minus J 0.0354. Next is 6 angle 20 degrees becomes 5.64 plus J 2.05. And 4 angle negative 30 degrees becomes 3.46 minus J2. Next, we form two equations based on node 1 and node 2. So, at node 1, 0.1 V1 plus 0.0354 minus J 0.0354 times V1 minus V2 equals 5.64 plus J 2.05. Now let's simplify it. 0.1354 minus J 0.0354 V1 minus 0.0354 minus J 0.0354 V2 equals 5.64 plus J 2.05. At node 2, 0.0667 V2 plus 0.0354 minus J 0.0354 times V2 minus V1 equals 3.46 minus J2. Let's simplify again. So it becomes negative 0.0354 minus J 0.0354 V1 plus 0.1021 minus J 0.354 V2 equals 3.46 J2. Then we will solve the simultaneous equation using elimination method. So let A V1 plus B V2 equals to C and D V1 plus E V2 equals F, where A equals to 0.1354 minus J 0.0354, B and D is a same equation as negative 0.0354 minus J 0.0354 and E 0.1021 minus J 0.0354. Now let's simplify B and D. Negative 0.1354 minus J 0.0354 V1 plus negative 0.0354 plus J 0.0354 V2 equals 5.64 plus J 205. That will be equation number 1. Next, negative 0.0354 plus J 0.0354 V1 plus 0.1021 minus J 0.0354 V2 equals 3.46 minus J2. And that will be our equation number 2. Now let's proceed to elimination method. Multiply equation 2, so the coefficients of V1 cancel. So the equation becomes 0.1354 minus J 0.0354 over negative 0.0354 plus J 0.0354 equals negative 2.19 minus J142. So 0.1354 times J 0.0354 V1 plus negative 0.111552 minus J 0.021 V2 equals 3.20 minus J 685. That will be equation 2 prime. So subtract equation 1 from equation 2 prime. 0.1354 minus J 0.0354 V1 plus 0.0354 plus J 0.0354 V2 minus 0.1354 minus J 0.354 V1 plus negative 0.1552 minus J 0.021 V2 equals minus negative 0.1178 minus J 0.0564 times V2 equals negative 884 minus J 890. Now let's solve for V2. V2 equals negative 8.84 minus J 8.90 over 0.1178 minus J 0.0564 equals 26.8 plus J 94. Now let's subtract or substitute back to find V1. We will use equation number 1. So 0.1354 minus J 0.0354 V1 plus negative 0.0354 plus J 0.0354, and we will use the V2 26.8 plus J 9.4 equals 5.64 plus J 205. Now let's multiply. Negative 0.0354 plus J 0.0354 times 26.8 plus 9.4 equals negative 1.32 plus J 0.61. Now let's substitute. 0.1354 minus J 0.0354 V1 minus 1.32 plus J 0.61 equals 5.64 plus J 0.5. Now let's move terms. 0.1354 minus J 0.0354 V1 equals 6.96 J 1.44. Now let's solve for V1. V1 equals 6.96 plus J 1.44 over 0.1354 minus J 0.0354 equals 38.5 plus J 16.2. So the rectangular form for V1 and V2 is or are V1 minus 38.5 plus J 16.2, and V2 is 26.8 plus J 9.4. And their polar form is V1 minus 41.8 degrees 22.8 volts, and V2 is 28.4 angle 19.3 degrees volts. Therefore, these are the nodes voltages using nodal analysis and phasor form. That concludes my presentation. Thank you for listening.